we know that the volume of a gas depends upon the amount of gas, pressure, and temperature. From the study of the behavior of gases, certain generalizations were made, and these generalizations are called gas laws. And these gas laws give quantitative relationship between any two variables when the other two are kept constant. So this here is a PV diagram, and you can clearly see that with the increase in volume the pressure is decreasing. So this is what Boyle's law actually is. Boyle's law says that with the increase in volume of a gas the pressure decreases, so that's volume is inversely proportional to pressure. That means exactly the same as volume is directly proportional to the reciprocal of pressure. So I can also write that's equal to V, no, let me write here. So that's V is equal to K by P, and that's my proportionality constant called specific gas constant. So I can write PV is equal to K by like multiplying both sides by P. I can write PV equals to K. And if the pressure is changed from P to P1 and then the volume will change from V to V1, then that's P1V1 equals to K. In the same way, P2V2 will also be equal to K, and that's the expression of Boyle's law. That's P1V1 equals to P2V2. That's the expression of Boyle's law. So in 1662, Robert Boyle studied the changes in volume of a gas by varying pressure at a constant temperature of a fixed amount of gas. And he had used a J-shaped tube to verify this. But let me just verify this real quick here with help of two pistons. So that's my piston. One more piston. So here I'm applying a pressure of 1 atm 1 atm pressure. Then the volume of the gas will be 2 liters. But here I increase the pressure to 2 atm. Then the volume of the gas will decrease to maybe like, I don't know, okay, 1 liter. So that's my 1 liter gas at 2 atm pressure. So this is just simple. Alright, so this is how Boyle's law works. Now we can plot a lot of graphs to verify Boyle's law. One of the first graphs is this PV plot, where you can see that with the increase in volume the pressure is decreasing. So this is your first graph to verify Boyle's law. Second graph we can plot is the pressure versus the reciprocal of volume plot, which will look kind of like this. That's my pressure over there, and then volume right here. So if I plot pressure against the reciprocal of volume, then I'm gonna get a straight line passing through origin, which means it says the reciprocal of volume increases with the increase in pressure. So pressure is directly proportional to reciprocal of volume, and that means pressure is inversely proportional to volume. Another graph we can plot is PV, the product of pressure and volume, versus pressure. Let me just turn my graph real quick. So that's my product of pressure and volume here, and then pressure right over here on the x-axis. I'm gonna get a straight line that will be parallel to p-axis, which shows that the value of PV is always constant, and that's the Boyle's expression right here. Boyle's expression, product of pressure and volume, is always constant. And finally, I can plot a graph for log P versus log V. That way I'm going to receive a straight line which will have slope equal to -1. That's my straight line, guys. So that's log P here, log P, and that's log, oh my god, let me just write this again, log P, and that's log B. All these graphs verify Boyle's law.